Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 3rd. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. Little area of low pressure here in the Gulf of Alaska generating, 16-foot seas or so, and a broader area in the western Gulf of Alaska doing about the same thing, but none of this is capable of generating swell of any interest relative to our forecast area, which is mainly the U.S. West Coast and Hawaii. Let's dig into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. We're looking for a trough, that is a dip in the jet, just like this. That would help support low pressure aloft and down at the surface, which of course generates winds. Winds generate seas. Seas generate swell that radiates away from the fetch area and eventually creates surf at your beach. So we do have a bit of a trough here, and the jet is sort of consolidated, but notice this. It's forming a split pattern actually here off of Japan. That steals energy from it. Then when the jet comes to get back together, it consolidates, of course, creates more wind energy, but all that wind energy is in the east side of the trough, and really what you want it is over in the west side of the trough, that is coming down. That would support all the winds in the western and southwestern quadrants of the gale, therefore aimed at Hawaii and the U.S. West Coast. This would push all the energy, assuming a trough or a gale was forming here, up towards Alaska. Anyway, jet is consolidated, pushing north of Hawaii, and then it splits again with a little mini trough here in the Gulf, not doing a whole lot, and then most of the energy, it almost seems like, running into Baja. And as you recall from looking at the significant wave height chart, we had a little bit of a low pressure here, a little bit of a low pressure here, not doing a whole lot. So all this kind of makes sense. Let's roll this out. As we get into Monday or so, the trough continues into the Gulf of Alaska. Notice, big split here off the U.S. West Coast. That creates high pressure down at the surface. High pressure, especially in this location, would tend to generate a lot of wind along the U.S. West Coast. Anyway, the trough continues off to the east. Also, notice the split dissipates here off of Japan, which is a bit of a good thing. The trough pinches off Wednesday in the Gulf of Alaska, and we'll roll this out some more, and then continues. Notice more wind energy building. This is a rather strange pattern. It almost looks like one part of the jet here, another down here, almost like a massive split, but not quite. It's semi-holding together. Anyway, we get this bit of a cutoff trough here off the U.S. West Coast on Friday. Maybe that's good for some surface level low pressure at best, but nothing more. This trough here looks better Friday on the dateline region or so, with notice winds in the 140 knot range in the west side of it. Better for supporting gale development. And we'll roll this out to about 100. We'll just roll it out. Notice a bit of it's split here, but it almost looks like there's a trough trying to dig in off the U.S. West Coast come Monday or late Sunday. If that were to happen, that might actually support some precipitation in this area. A little bit more wind energy trying to organize in the jet, but just nothing clearly like yelling at us saying, oh, storm development. Instead, it's kind of this piddly stuff, a little bit of a trough here and there, not quite ideal, not quite enough wind energy, whatever. So the short of it is not a super lot of good support in the upper level for surface level gale development. So that's our estimation of what's going to go on at the surface based on the upper level models. Let's see what's actually going to happen. This is the nice little game we try to play. Look at the upper level picture, see if it translates down at the surface, see how well the model is in sync at different levels of the atmosphere. As we expect, small low pressure here in the Gulf of Alaska, another one here in the western Gulf, not a lot of fetch. What's that, 20 knot winds, maybe a little bit of 25, not enough to generate any seas of interest, and therefore no swell generation capacity in our estimation. Winds get up to 30 knots there on Monday, but just really isn't doing much. Things are looking a bit better here come Tuesday. Low pressure starts to develop here, approaching the North Dateline region. Small area 45 knot winds Tuesday night into Wednesday, but then most of this starts moving into the Bering Sea, gets cut off by the Aleutians. Probably not a whole lot of anything happening there. Now remember, we saw steep troughs pushing here into the Gulf, and sure enough, here we go. A small area of 40 knot winds forecast on Thursday off of northern California, southern Oregon, falling southeast, that winds down to 30 knots by Friday, and then the whole thing kind of peters out. Another two paragales here, one with 35 knot winds, another with 45 knot winds on Saturday, tracking into the western Gulf, sort of fade out. So again, another kind of a lackadaisical pattern, and then a broader sort of low tries to organize here. Broad low pressure over, I will call it the western Pacific, high pressure over the eastern Pacific. Not sure how this will all play out. It's a week out, hardly believable. We'll see. The short of it is, at the surface, not a whole lot going on, little bits and hints. So, I mean, the gales we did see, probably good for some 13-second period swell, small size. It's better than nothing at all. Summer will be here soon enough, and we'd be crying to get whatever is going to be generated over the next week. So take it for what it's worth. And then finally, let's take a look and see what effect those surface level winds have on the actual ocean surface in terms of generating waves. As we saw, small gale in the Gulf not doing a lot, another one here in the western Gulf not doing a whole lot. Roll this out, and really just nothing going on until we get into Wednesday. That system that's forecast for the North Dateline region generates, what was that, 26-foot seas? That's about it. But also notice, relative to the Great Circle Pass into the U.S. West Coast, that's a good portion of that. If we go here, that's not obscured. But once you get north of this southernmost point of the Aleutians, the Great Circle Path goes like this into California, and it'll all get cut off. So not a whole lot from that. Then we get into the Thursday, Friday gale off the U.S. West Coast, 20-foot seas, maybe 21-foot seas for a moment, then falling southeast and fading out. That's still good for maybe some small 13-second period swell for the U.S. West Coast on probably Saturday. Pair of gales here was at 22-foot seas on Saturday in the western Gulf, and 32-foot seas west of the dateline. Good for swell for probably Hawaii from both those, and a little bit for the U.S. West Coast. That all peters out, and then we're at the end of our time frame there. So a little bit of hope, but nothing super significant. And we had a nice little run of southern hemi swell over the weekend into Southern California, and that swell also made it up into Northern California, but it was all heavily masked by west swell that was more dominant. Either way, swell is swell. There were waves all along the U.S. West Coast. Good deal. Now let's see if there's anything coming from the southern hemisphere, and we're kind of looking here just real close. We see a gale, almost a storm developing here off west of Chile on about late Tuesday, but Southern California swell window cuts off right about here. Odds are nothing will result from that. It's all relative to Chile. They'll get some swell from that. Southern system here, what is that, 26-foot seas and tracking southeast. Nothing expected from that. Roll this out, a cutoff low south Tahiti, not doing a whole lot. And we're out 180 hours. And until you see about 30-foot seas down here, relative to the U.S. West Coast and Hawaii, you're not going to get a whole lot, and it needs to be aimed pretty well to the north. So the southern hemi is taking a bit of a nap for a while. Let's go look at long term, see what's going on. So here we go. We're looking at 850 millibar winds. These are about 4,000 feet over the Pacific Ocean, specifically in the Kelvin wave generation area, which is roughly on the equator. Draw a box from about 170 west out to about 130, so right in just this one little area here. We see a little bit, the oranges and red are west anomalies. We see that was as of March 28th, and we'll just sort of roll through here. You see this continued patch of westerly anomalies in that area, just barely in the Kelvin wave generation area. Most of it's down from 5 south and points south of there, but it suggests maybe a little hint of support for the jet stream. And the current image from the TAO buoy array actually buoys down at the surface, suggests west winds here, right as we expected. There's a New Guinea there. Dateline is right here, so the Kelvin wave generation area is right this box down to about here. We see west winds here. There's actual anomalies and west anomalies. That typically tries to feed the jet stream a little, but it's very weak. I mean, you really want it more in the dateline area and stronger, so not a whole lot going on there. And then here's actually down at the surface, the GFS model. Here's the Kelvin wave generation area, the main area 3 north and south, and the stretch area out to 5 north and south. And here is our west winds right here, just this one little pocket associated with low pressure down here. We'll roll this out and see what the forecast shows. And those westerly winds are supposed to fade south, associated with low pressure here south of not even Tahiti, just in the Southwest Pacific. Roll this out. Trades over the northern half of the Kelvin wave generation area, pretty brisk in the 18-20 knot range or so, but generally still a light wind pattern. This is typically you'd see trades across all this area, that is east winds, and pretty brisk this time of year, but El Nino is suppressing the trades, that is creating westerly anomalies. That helps the jet stream, but doesn't do a whole lot for it because they're not like a real westerly wind burst or anything going on here. So the short of it is the forecast for this week per this is pretty much just a normal, if maybe a light westerly anomaly pattern. And here's yet another view. This is the whole world on one chart. The date line runs right down the middle of it. This is looking at past earlier in March. The oranges, the reds, yellows are westerly anomalies. We had a little pocket here. Another little one that ran into the latter part of March. But as you can see, that pretty much ended today. The forecast for the next week is maybe a hint of easterly anomalies, no westerly anomalies. Suggests pretty much the fading part of El Nino and not a whole lot to support the jet stream, though the models suggest some sort of very weak westerly anomaly pattern here. But again, mainly east of the Kelvin wave generation area. It starts here again at about 1:30 and goes in this region here. So not a whole lot for the next week projected on the charts. And the westerly winds, of course, they're all about trying to support the jet stream or create Kelvin waves. Now, at this point in El Nino's life cycle, no Kelvin waves are expected to result. What is a Kelvin wave? Well, you get westerly winds. This is a subsurface view of the ocean, West Pacific here, East Pacific here, down depth 100 meters, 200 meters, 300 meters, and this is actual water temperatures. You see warm water sort of piled up here in the West Pacific, and when you get El Nino, this warm water starts tracking to the east. You can see the 28-degree isotherm still shows a very shallow, thin layer of warm water the whole way off here to Ecuador. Okay, but that is steadily getting shallower. It's actually the anomalies, differences from normal for this time of year. What you would normally see is a lot of warm water here, a lot of cold water here, and trades in control causing upwelling off of Ecuador, and that would result in the cooler water flow. During El Nino, you get westerly anomalies in this region, the Kelvin wave generation area. That takes the warm water that's normal here, starts pushing it off to the east in pockets, in one big pocket, let's say, and that's what is a Kelvin wave. It travels the whole way under the Pacific, west to east, eventually gurgles up off of Ecuador and warms the surface water there, and we basically end up with a reverse of the normal heating distribution with, instead of warm water in the west, it cools down and all your warm water shows up in the east. So you can still see remnants of El Nino here, actually 1 degree anomalies, and there's the 0 degree anomaly line, 1 degree anomalies and 2 degree anomalies, and almost a little patch of 3 degree anomalies off of Ecuador here. So still some remnants of El Nino still in play in the ocean, which is a good thing. That also helps to fuel the jet stream a little bit, but not a super marked pattern here. It was up to 5 to 6 degrees at one point in the fall and early winter. Things are slowly mellowing out, and of course we see this pocket of -2 degree anomalies, cooler water starting to work its way from the west to the east. This is what appears to be a pending La Nina setup here. As this warm water starts, it's getting caught. Notice there's there's trade winds across the entire equatorial Pacific. Eventually, this warm water will bleed off this way, and then that will open the door for this cool water to push up here, and then that would be the start of La Nina. Instead of warm water in the East Pacific, it would be cool water, and that's a hallmark of La Nina. Another way to look at this is from the Jason-2 satellite. It goes in, if you strip out all the actual waves, strip out all the chops, strip out the tides, and you just look for differences in normal for the height of the ocean. That is, and we're talking in centimeters here. And normally if you had El Nino, you'd had 5 or 10 centimeter anomalies in this area. Here's Ecuador, here's here's Ecuador, here's the Galapagos, Peru's down here. And even just a month ago, that was the case. Now notice anomalies, negative anomalies. So warm anomalies suggest, or positive anomalies, 5, 10 centimeter anomalies like here suggest warm water at depth, but it's right here on the equator that really matters in terms of El Nino. And with negative anomalies, that suggests cooler than normal water at depth. That is, warm water at depth expands, creates a bump on the surface, hence this sort of thing. Cooler water contracts, creates sort of a trough, 5, 10 centimeter anomalies here. Just like what we saw on the other chart, cool water is on its way, making it to the east. Again, a signal of La Nina. We didn't show this one earlier. This is the same subsurface profile that we saw just 2 slides ago. But notice here, the warm water is actually breaking up into 1, 2, 3 different pockets. Again, suggesting this is a higher res view, and just one little pocket here of 2 to 3 degree anomalies. Most of this is 1 to 2 degree anomalies, suggesting this cool water is marching steadily to the east, and things are breaking up. The warm pool is dissolving. And then also yet another view, upper ocean heat anomalies, upper 300 meters. These reds and grays are higher or warmer than normal water temperatures. Basically, you can watch Kelvin waves. Kelvin wave 1, 2, 3, 4, Kelvin wave 5. This was in February. And notice after that, here's cold water in the West Pacific starting to work its way to the east. The last little bit of really warm water, and that's only a half to 1 degree. This is down at depth. Is down, only making it to 85 west now. So that's actually the other side of the Galapagos, the east side of the Galapagos. This also suggests La Nina is on its way. And then, of course, a look at the surface water temperatures. So we talked about westerly wind anomalies, taking warm water here, pushing it depth, creating Kelvin waves. That warm water boils up here along the Galapagos. And we still see clearly a warm water signal off of the Galapagos and Ecuador. What is that? Oh, roughly 2.5 degree anomalies maybe in this region. It was much, much warmer. And that's only in pockets, but still, El Nino signal is present for sure, suggesting that El Nino is not dead yet and still having some effect on the jet stream. Also, differences in normal the past 7 days. It's actually there was a bunch of real cooling in this area, but now we're seeing reds here suggesting that temperatures are warming slightly. Maybe there was some sort of strong easterly wind burst in here that sort of churned up the surface a little bit. Now that those winds have died down, temperatures are rebounding a little bit, but nothing too super impressive. Here's actual water temperatures again, zoomed in a little bit more. And notice we're seeing these pockets of 2.25 degree anomalies off of Peru, working their way up to the Galapagos, and then from the Galapagos out to a point not even south of California, maybe south of San Diego or so, but that's about it. This is rebounded a little bit, but also notice cooler water here, and this actually stretched over to here a little bit before it's backed off, but we think it's only a matter of time till it comes back. Still, warm water is present. On out to approaching the date line, warmer than normal. That suggests that some sort of El Nino signal still is in play. With that said, what we're really looking for is some sort of pulse from the MJO to goose up the jet stream. Unfortunately, per this model, these are the outgoing long-wave radiation models. Oranges and yellows suggest more outgoing long-wave radiation, suggesting high pressure, suggesting clear skies, suggesting the inactive phase of the MJO. And the inactive phase tends to negatively interfere or destructively interfere with El Nino and sort of suppress it. And that's why we think that we're seeing not a whole lot of energy in the jet stream, not a whole lot of support for gale development. If the active phase of the MJO were to show up, it would sort of supercharge supercharge the jet stream, and then we'd have probably a pretty good run of spring storms, but that does not appear to be the case at the moment. This is the statistic model. It suggests the inactive phase of the MJO is to build over the next 2 weeks. Here's the active phase hanging in the Indian Ocean. The dynamic model is a little bit more positive, but not much, suggesting that the inactive phase is just supposed to hang again over the dateline, but very weak, and that the active phase of the MJO isn't supposed to build any and is just supposed to linger here in the Indian Ocean. So just sort of a dead, almost a neutral pattern, and not helpful for the jet stream. Not so much destructively interfering with it, but certainly not constructively aiding it any and not supporting supercharging it. And we like this model a lot. We've seen it before. So this is, again, the, here, we'll just see if we can scooch this up just a little bit. There we go. So the date line runs right down here, but instead of running in this direction, past history, December 2015 is down here, and it goes towards the future. Oranges and reds are westerly wind bursts. Clearly one big westerly wind burst. I think there was number 4 here, number 5, or maybe this is number 5 and this is number 6 back in March. Here we are, current time. We'll overlay the MJO for you. Of course, both these westerly wind bursts were associated with the active phase of the MJO, these solid red lines. Supposedly, believe it or not, per this, the CFS model, the active phase of the MJO is in control over the date line, and it was forecast to be coming into play about this time, but some of the other models suggest otherwise, and based on westerly winds in this area, there are none, and it's very weak if there is any. Anyway, this model suggests that the inactive phase of the MJO is supposed to show up on the dateline about the 13th of April and run into about the end of April. Little bit of westerly anomalies trying to build here with another supposed weak active pulse of the MJO towards the end of April. Then the inactive phase comes back in. At this point, none of this looks believable. The combination of all the models together suggests we're just in an extremely weak MJO state, which I think is pretty normal about this time of year. And so it's not surprising that we're not getting a whole lot of aid for westerly winds in the Kelvin wave generation area, and therefore not a lot of support for the jet stream really doing its thing. Interesting, though, this model had been rock solid the whole way through this El Nino event and was projecting a strong westerly wind pattern here in the late April time frame, but it has since backed off, so again, no help here either. And the phase diagrams just sort of put a final stake in all that. So so if you're looking down on the North Pole and you're going counterclockwise around the Earth from the Indian Ocean to the maritime continent, over the dateline into the West Pacific, and then over the U.S., West Africa, and back into the Indian Ocean. This tracks the active phase of the MJO, suggesting that it is currently basically over Africa or maybe even East Africa. And the forecast here, the further away from the center it is, the stronger it is. The forecast for this, the ECMF model, suggests the MJO all but dead and not doing anything of any interest for the next 2 weeks. The dynamic model here, the ensemble GFS, suggests just the same thing. So really, no MJO pattern expected for the next 2 weeks. So then we start looking to see how well the atmosphere is coupled with the remnants of El Nino. That is, there's still warm water at the surface. We don't have the west winds we want to supercharge the jet stream, but we're still not in La Nina. We're still in El Nino. So we look at this, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest daily numbers suggest perhaps the active phase of the MJO, a long run of negative numbers. And notice this, starting about the 20th of March, we started getting into negative numbers here, and we're currently, today's value is -11. The 30-day running average -3.57. Now that suggests that we were look at the numbers here. They were in the -22 in earlier March, and they're going almost towards neutral now. Suggests that we're in kind of a dead phase of the MJO. But from an El Nino perspective here, here, this is the 90-day running average. We were a month ago, we were at minus 16. We're at minus 14.5 or more, minus 14.63. So El Nino is still in play, definitely, per the Southern Oscillation Index. And so one would expect to see more from the jet stream and the storm track than we're currently seeing. Now you can see here the 30-day running average. The spikes going up are the inactive phase of the MJO. The spikes going down are the active phase of the MJO. You can clearly see here we've been in an inactive phase. The question is this thing going to just sort of go down like this, or is it just going to keep going up for the near future? If it does, if it starts crossing over this line here, one would begin to wonder if it really is the final end of El Nino and it's over. Notice back in January 2014, we were up in this area and we had been way in positive territory for 2 years or 3 years prior to that, and then you could just sort of draw a line through this and see the average went down and sort of bottomed out here around in January, and it just has that sneaking feeling like the tide is turning in favor of La Nina. Not that that should be a surprise, as all the other data sort of suggests that as well. And finally, the SEI index, ESPI index, basically like the Southern Oscillation Index, just measures differences in precipitation between the area north of Darwin, Australia, and over the Nino regions here. Current value is 1. Positive numbers are good. They suggest El Nino. Negative numbers suggest La Nina. Right now, we're still in a good hangover or still in El Nino territory. It's actually been doing quite well, kind of holding on longer than we expected it would. But I guess that's not too unexpected because we had this El Nino just took a while to get going. And then once it got going, it was pretty good. And it had some late breaking Kelvin waves. And I think that's sort of helping to keep things lingering on for a bit longer, but just not enough to really do a whole lot atmospherically. So for now, we're kind of in a pause, at least, with a weaker storm track. We're also in the change of seasons. We've had a southern hemi swell recently, which sort of hints that maybe we're moving towards a summer pattern. Certainly springtime is here. So the North Pacific isn't too active right now or for the next week, though it does look to be getting a bit more active a week out if one is to believe the models. So we'll just have to wait and see. Basically, the strategy should be if you can get waves, go make the most of it, because there's no sure bet that there's some mega swell coming from here on out for at least a while. The long-term models in regards to El Nino clearly suggest that El Nino's on its last legs. It's starting to dissipate. La Nina is likely on its way. The temperature models suggest, in fact, that we will move at least to a neutral state, if not perhaps a weak El Nino state by the fall. Not horribly so, like minus half a degree temperatures are what is forecast. So that wouldn't be horrible. And we'll just have to wait and see. There's still the whole discussion on what's going on with Pacific Decadal Oscillation. Nothing's changed. That data only gets updated once a month, but we'll keep our eye on that. Right now, it kind of looks like we're moving into a long-term sort of positive phase, the Pacific Decadal Oscillation. So that would mean 15 years of conditions favorable for El Nino development, unlike the past 15 years that have been the equivalent of a long-running La Nina. But it's way too early to get too excited about any of that yet. So that's it for this week. I'm glad, I hope you enjoyed watching, and we'll do this again next week. Same time, same channel. Thanks for watching. Bye-bye.